Hello everyone. So in this session I am going to demonstrate you how to use Modeler for performing advanced homology modeling. And for doing this exercise we need some software, and these are the softwares which are required for doing this exercise. So you have to install Modeler. You can download and install from this salislab.org. So we also need Python. So you can download from the python.org web address. So also you may need some additional packages for Python like NumPy, SkyPy, Matplotlib. These are the packages which I'll be using for generating some energy plots. So I highly recommend you to download these packages for the Python. So needed files, I have given link for the needed file for this tutorial. So the file is modeler needed file. The link is given in the Google Classroom. So I kindly request you to install all the software properly before trying to do the modeling practically. So for this demonstration, I have taken the target sequence as lactate dehydrogenase, the protein sequence of lactate dehydrogenase from Trichomonas vaginalis. So the lactate dehydrogenase from Trichomonas vaginalis, the protein structure is not yet solved experimentally. So we have chosen that protein as the target protein, and we are going to model that with the help of some template. And these are the steps which we will be following for this. So the first step is searching for structure related to TVLDH. So we have to find suitable template by searching for the structures related to TVLDH. Then we have to select the proper template, and we have to do the alignment between the target and the template, which is TVLDH and the template. And finally we have to do the model building, and we have to validate the model building. So this part is not advanced one. This is a basic one you might already studied in your molecular modeling course. So anyway, we need the output from this model to take it further for the advanced modeling section. So I just wanted to start with the basics, right? So once if we complete that section, we go for some advanced modeling concepts, like I'm going to demonstrate you how to model protein ligand complex. Because sometimes you may want to model the protein along with the co-crystallized ligand molecule or some other ligand molecule. So I'm going to give the demonstration for how to do that. Also, I'm going to demonstrate you how to use multiple template for improvising the quality of the model. Then if you have some issues with any of the loops in the model protein molecule, I'll be demonstrating you how to refine. How to perform the loop refinement using the modeler, and finally we will see how to give some constraints, or how to model with the help of some specified restraints. So these are the three topics which will be covered under the advanced modeling concept: multiple template, how to use loop refinement, how to do that, and modeling ligands in the binding site. Right. So this is what I have planned for demonstrating in this session, and so you can download the modeler software from this website. So depending upon whether your computer is either a 64-bit computer or 32-bit computer, so you have to choose the proper version. And I highly recommend if you download Windows 64-bit for your computer. So Python also you have to download for Windows 64-bit, and if you install Windows 32-bit modeler on your computer, I strongly recommend you to install Python 32-bit. Okay, so don't go for 64, 32, 32, 64. It won't work. So both modeler as well as the Python, it should be of either 64-bit or 32-bit, right? So with that, let me show the needed files. So this is the folder where I have kept all the needed files, so which is under modeler needed files. So again, this folder contain subfolder. So we have a PDB folder which contains the PDB files which I already downloaded and kept. So this is a very important folder where we have the Python script. So I splitted this Python script into two sets, set 1 and set 2. So set 1 will be used for the basic modeling, and set 2 will be used for the advanced modeling purpose. And so we have PDB 95. So this is the file which contains all the sequences of the PDB structure deposited in protein data bank, and this is the target sequence at tvldh.ali. Okay, so let me put it here. So this tvldh.ali, this file is our target file. Okay, so I hope that you know what is meant by target. So target is the protein sequence for which there is no experimentally determined structure, and we have to model. We have to model with the help of a proper template using the homology modeling approach. So this PDB95, this file contains the sequence of all the protein molecules which are deposited in protein data bank. You know, for finding out the template, either we can do the BLAST online, or we can use this PDB95 and using the modeler script we can do it offline itself, right? So I am going to demonstrate how to find the template using offline, not online. So we are not going to run anything on NCBI BLAST. Everything I am going to do offline, right? So I think with that basic information, I think we can now go on to the demonstration part. So let me show how to open Modeler, right? So I have already installed Modeler. So as I said that I have installed Modeler 10.1 version. Okay, so 10.1 is the latest version. I strongly recommend you to install the same version, right? So it will be easy for you to follow the demonstration purpose, right? So I'm going to show you how to open this Modeler software. Go to Start menu. So from the Start menu, you have to type simply the Modeler. Okay, so you can see some command prompt like this. This is not the default command prompt of Windows. So this is the command prompt of Modeler, right? So so we have to open this by clicking that. So you will get some window like this. So this is perfectly the working environment for Modeler, command prompt for Modeler. So everything we are going to run in this Modeler command prompt, right? So very first thing is I just wanted to tell what is the command for running the how to run the Modeler script. So the command for running Modeler is, so let me write it here. So the command for running Modeler is mod is the command, mod, then the version which you have installed on your computer. So on my case it is 10.1. So I am going to for me the command for running the Modeler is mod 10.1. Okay, so mod 10.1 space the Python script .py. Okay, this is the command for executing the Modeler script, right? So let me show that. So let me delete this from the screen, right? So okay, so very first thing is we have to direct this to the location where we have all the input files, right? So for that I have kept all my files inside this folder, Modeler needed file. So in this folder I am going to create another folder just for avoiding any confusion, right? So I'm going to name this as I am going to name this as model. All right, so now this is my main folder, right? So I'm going to make copy of the needed files into this model folder, and I am going to execute, right? So first thing is I need this PDB95. So I need this tvldh.ali, and I need okay. Okay, so the first thing what we are going to do is the first thing what we are going to do is that we are going to search for the structures which are related to TVLDH. So let me show the target sequence TVLDH, right? So in this folder we have tvldh. So in this folder we have tvldh.ali. Okay, this is our target sequence. So I'm going to show display in the Notepad++. So here this is the target sequence, right? So as I said, the target sequence is the one for which So target sequence is the one for which there is no experimentally determined structure and we have to model structure with the help of some templates, right? So the syntax of this file is very important. So this syntax is called as a PER file format. So it starts with greater than symbol, then some information about whether it is a protein sequence or nucleotide sequence, then some annotation, so maybe the name, short name of the protein sequence, and you should not disturb any of this colons or spaces. So if you do so, you will end up with some kind of error, and end of the sequence you have to paste this asterisk symbol, and this is absolutely example for the target sequence in PER file format, and that is the input file format, right? So tvldh.ali. Okay, so I'm going to direct my location to this folder first. So go to cd space, so enter and give dir, right? So right now I am in the folder, right? I am in the main folder. So I had to get into the model folder. Okay, so where I am going to run, I am going to keep the needed files and I am going to run. So first thing is I am going to copy script 1. Okay, so the script 1 is I am going to use this build profile.py. So I'll show what is the content of this script and what is the use of this script in a moment, right? So I copied this file. So let me open this file using Notepad++. So this is the Python script, right? So this is the first script we are going to use for searching for the template. So what are the input file for this? As you might already studied Python, so you can easily understand the code. So let me show the important places where we are going to make some changes, right? So here it is asking for the sequence database file. This place, sequence database file. So the sequence database file already I have kept in the needed file folder. So that is the pdb95.par. This is the first file which we need. So the second file what we need is we need the target sequence in .ali file format. So already I have given the link for this tvldh.ali file. So it is going to output build profile.ali. So we can expect this as the output and also this build profile.pfr as the output once if we run this script, right? So I'm going to copy two files to my folder, okay, working directory. One is this pdb95.pr and the second one is this tvldh.ali. So let me copy that. So I go to the script folder. So where I kept, okay, I think I already copied the script file, no? Yes, it is already there, build profile. So we have to copy those two files, pdb95. Here we have the pdb95. I make a copy and paste it inside my current working directory, which is the model folder. So also I need the target sequence tvldh.ali. So I copy and paste it to this folder, right? So these are the two files which are required for running this first script build profile for searching for the suitable template. All right. So let me delete this annotation. Okay. So I'm going to now run this file. So how to run this? So I'm going for my current working directory. So cd space. This is my current working directory dir. So I have three files. Two input file pdb95.pr and tvldh.ali and one script file. So I am going to run the script now. So how to run that? As I said, mod the version number for me the version number is mod 10 point, so you can find it here, mod 10.1 in my case. So mod 10.1 space. So the script file name is buildprofile.py. okay, just enter. So you will get something like this, like import site failed -v for traceback. Okay, no need to worry that the program is perfectly running. So we have to wait for a couple of seconds or minutes for the program to output all the output files, right? So now you can see here the job is over. The line got terminated. So the next line, it has appeared here. So here parallelly you can see that a few more files which are generated. So initially we had only 3 files, now we got more than 3 files, which means that we got some output file. So one of the output file is important output file is this build profile.txt and this build profile.ali. So these are the 2 important files after running the first script. So let me open the first file and show what is the content of this build profile.txt. Okay, so I'm opening this file. So here you can see the file is open using text editor. So if I scroll down, you can see some kind of calculation part, and you can see that how much time it took for completion, everything is given here. So this is very important area. So here if you look at this region is very important, right? So here, so what it does is it made some sequence comparison, and all the sequences which are present in PDB95 are compared with the target sequence at tvldh.ali, and it output the sequences which are highly similar to this tvldh.ali. So these are the sequences. Okay, so these are the PDB IDs basically, right? So these are the PDB structure whose sequences are highly similar with the target sequence at tvldh.ali. So it has many columns. The output is organized column wise. So this column is the PDB ID and the A, B, or this is a 4-letter code of PDB ID, and this A or B, in this case we don't have B, right? So this A, if you have this A, which means that protein molecule has more than one chain, and this is the chain identifier, which chain is having the higher similarity with the target sequence at tvldh.ali, right? So this column is very important. This is the second column, and the 11th column is very important. So if we okay, so this column is very important, and this column is the sequence identity column, and this column is the E value. So here this is the E value, right? So I can highlight here. So the columns which are important for the analysis for choosing the template. So this is the PDB ID, and this is the E value, and this is the percentage identity, right? So these are the 3 columns which are very important. And okay, so as you studied in the theory that the quality of the final model which mainly depends on the template that we choose, right? So here if you compare 1A5Z, which is having the E value 0.85 into 10 to the power of minus 0.8, 1B8PA, it has 0 as the E value, right? So 1BDMA, which has 0 as the E value. So based on this percentage identity, based on this E value, we can get some idea, right? So we can pick up some template, good templates. So always we prefer for the E value 0, right? So here we have E value 0 for almost 3, 4, 5, 6 entries, right? So these are the entries which are having the E value as 0. So 1 as MKA. Then here 5 MDHA and 7 MDHA. So then we have 1 CIVA E value as 0, 1 B8PA, 1 BDMA, right? So the sequence identity of the sequences are given here: 42.50, 44.52, 44.41, 33.74, then 33.85. Not bad, right? So we have to somehow pick which template is the suitable template for modeling the tvldh.ali. So for this case, so we have another script which will help guide us to choose which template is the best template. So what I'm going to do is I'm copy the script. Okay, that is called as compare.py. Okay, so it is going to compare, and it's going to tell which templates are the best template for our modeling purpose. So I copied it here. So let me open this compare.py. We will see what is the input for this compare.py. So I'm going to open this using Notepad++, and this is the script. we are going to use for comparing and choosing which template is the best template. So this file asks for which PDB structure has to be compared. And so here if you look at so 1B8P, okay, 1BDM, 1CIV, 1MDH, 7MDH, and 1SMK. So let me show the build profile, right? So here, let me show the text output which we got here, right? So if you look at this 1B8P of A chain, okay, which has the E value 0, 1BDMA which has the E value 0, 1CIVA which has the E value. So all the entries which are having the E value 0, so which are chosen here, one as MKA which has the E value as 0, right? So all the entries which has the E value 0, so which are listed here. So for running this script, first what you have to do is that you have to identify which PDB entries are having the E value 0, and you have to download the corresponding PDB entry from the protein data bank. For the simplicity, what I did is I already downloaded those protein molecules in PDB file format, and I kept that in this folder called as PDB. So we can directly take from this folder, right? So I didn't do anything special, right? Just I went for protein data bank. I have downloaded the PDB files. So just for reducing the time, right? So I'm going to copy the files. So I need 1B8P. So I need 1BDM. I need 1CIV. 1SMK, then 5MDH and 7MDH, right? So these are the entries which had not this 2MHD. Okay, so I just unselect. So these are the entries which we need, right? So 1, 2, 3, 4, 5, 6 protein entries. So 1, 2, 3, 4, 5, 6, right? So I copy this and paste it inside the folder called as model, because that is my currently working directory. I have modeled this. So I have to copy the script now. So the script file is in compare.py. So I just copy this compare.py and paste it in my current working directory. So model compare. Already I copied this file, right? So yeah, fine. So what I'm going to do is that any input file, no input file. So it is going to generate some output file like family.mat, right? So we will see that after running that. So what I'm going to do is that I'm going to open and I'm going to execute the second script file called as compare.py. So let me run it. So the command is the same, mod 10.1 space the script file name. Here the script file name is compare.py. Just I am running this. So again you can see that import site failed -v trace back. No need to worry about that. That is not error. So the program ran successfully. The script ran successfully. So we got the line terminated in the command line, which means that the process is over. So here you can see now some new files which are generated. So you have the text file compare, right? So I'm going to open that file compare.text. So let me show it here. So I'm going to open this is a newly generated file compare dot text file, text document. So this is a newly generated file, output file from the previous run. So I'm going to open that file using text editor. So I'm just going to open this compare.text. So I have opened this. So here you can see some kind of calculation work done with the help of that script. So if I scroll down, yeah, this region is very important, right? So so let me highlight that. Okay, so this region is very important. This will guide us, will give some idea about how to pick up which template is the best template. So this is a kind of dendrogram, what you might study in your phylogenetic analysis. So it tells that which sequences are highly similar, and if you look at the one which is highly deviated from this is 1SMKA. So this 7MDHA and this 1C IBA, they have a good relationship. So 5M DHA, 1B DMA, and 1B 1B8PA, right? So based on this, we can say that based on the resolution, right? So we can say that most probably, so this one is the best one for choosing as the template, 1B DMA, because its resolution is 1.8, right? So the quality of the template is good. Also, it is having good similarity with the target protein sequence, right? So here one-to-one comparison is here. You just go through that. So based on this, we can say that it is better to go with 1B DMA as the template, right? So let me erase this annotation, right? So we have as of now we have chosen this 1B DMA as the template for our modeling purpose, right? Okay, so next we move on to the next step. So the next step is that let me erase the annotation. Yeah, so the next step is that we have chosen our template. So our template is 1B DMA. So our template is 1B DM of the A chain. Okay, so this is our template. So using this template, we are going to model TVL DH.ALI. Okay, so for that we need another script. So I just go for script folder. So I have to make the alignment here. Okay, so for making the alignment, I think I didn't keep the file. Let me take the file. So what we need is we need this align2d.py. I copied this to my folder, right? So this script I have to copy to my working directory align2d.py. So I am copying that align2d.py to my current working directory model. Okay, so this is the file we are going to use for making alignment between the target sequence and template structure. Okay, so let me open this align2d file. So I just wanted to show what's the content of this align2d file. So let me open this using edit with Notepad++. So I have to open this using Notepad++. Edit with Notepad++. Yeah, it is open here. So we will try to understand how to edit this align2d for executing the alignment between the target and template. So here the first thing is, what is the PDB entry? What is the template we have chosen? That information should be given. So here the align code along with the chain identifier, the alignment should be made with 1BDM of the A chain, and the PDB file name is, we have the same PDB file name 1BDM.pdb. So the final output file from this will be tvldh.1bdma.ali and tvldh.1bdma.pap. So these are the two output files we will get after executing. So all the input files already within our current working directory. So we are not going to do anything. We are not going to add anything new, right? So we're going to execute this align2d. So I'm going to give the command mod 10.1, then align2d.py. So what it's going to do is that it's going to align 1BDM of A chain with tvldh.ali. So let's see. So again, we got import site failed, use -v for traceback, which means that the program is perfectly working and the alignment is over. It's very fast. So here, as we said that we got two new output files. So let me show that. So these are the two output files, import and output files that we got. So one is tvldh 1bdma.ali and another one is tvldh.1bdma.pap. So let me open this PAP because it will be easy for us to read the alignment. Here the alignment is made between the target and the template. 1BDMA is the template and this is the target. So this is alignment made between the target and template. So if you look at the alignment, some cases we have the identical residues which are highlighted as asterisk symbol. Some places we have the gap. Okay, so we'll talk about this later. So maybe between 100 to 110, between our 90 to 110 we have some gaps in between. So this is the alignment file. So let me open this tvldh1bdma.ali file. So that is also alignment file, but represented in different way. Okay, so let me erase the annotation. So it is represented in a very different way. In the top we have 1BDMA sequence and bottom we have tvldh. So this is also aligned file. Okay, this is also aligned file. The computers, they can easily read this. The human, we can easily read this .pap file. Okay, so that is the output file which is generated. So we made the alignment. So the next step is we have to go for model. So we are ready for modeling. So for modeling, we have to copy the script that is needed for modeling. So already I have given that script on the script folder set1, and the script is model single.py. So I just copy this model single.py and paste it on the current working directory model. So I pasted the file. So let me show what is the content of this file. I am opening this using Notepad++. So this script is very simple. Let me do the annotation. So this script is very simple. So it is asking for what is the name of the alignment file which we have generated in the last step, which is a tvldh 1bdma.ali. Even though we have .pap, so we have to use only .ali for modeling purpose. So known means that for which the structure is already known. So we know the structure of 1bdma, that is the template. Okay, so sequence is the target sequence for which the structure is not known, which is tvldh. So these are the information that we have to give, how many models it has to generate. So here we have given the starting model number as 1 and ending model number 5, which means that so it's going to randomly generate maximum of 5 models, and we have specifically given access the model with the help of the dope scoring function. So it is going to also GA341. So it is going to evaluate the model based on this dope and GA341. So which will give some idea about which model is the best model after getting model from the modeler. So with that knowledge, I think we can run this script now. So I'm going for the command prompt. So I'm going to give the command mod 10.1 space. So the command here is model single.py is the command, right? So let me run this. It may take a few minutes because we have given 5 models, right? So the software may take some time for modeling 5 models. So we had to wait for the output, right? So finally we got the 5 models which got generated. So here you can see that the terminal got in the command line the line got terminated. So which means that the job is over. So here you can see that the 5 models which are outputted as PDB file format. So these are the 5 models which are generated. Okay, so here you can see these are the 5 models which got generated. So we have 5 models. We have to find which model is the best model. So we have to do kind of evaluation, quality evaluation. So how to do the quality evaluation? So before going for quality evaluation, so let me erase the annotation. So before going for quality evaluation, so first we have to check the energy of each model. So that is given in the file model single. So let me highlight that. So that is given in model single file, this file. So what I'm going to do is that I'm going to open this file to check what's the energy of each model. So that will give some idea that which model is having good energy. So I just opened this using Notepad++. So here you can see the output file. Just scroll down and go to the bottom, right? So here, so this part is very important. Let me make annotation here. So this region is very important. So these are the this is the place where we have the energy of all the 5 model. So B99990001.pdb is the first model, and this is the second model, this is the third model, fourth model, and fifth model. So in the model single, okay, so in the model single.py script, so we ask the software to evaluate based on the energy. We asked to create the energy profile of each model. So it calculated 3 values. One is the mol PDF value, another one is the dope score, another one is the GA341 score. This GA341 score should be 1, and all the models they have 1. So this dope score, since this is energy value, it should have higher value in negative, and the mol PDF value, it should have lesser value, right? So here if you look at based on the dope score, we can say that we can say minus 378.6, right? So we can say that second model seems, you know, good based on the dope score, and also you know, the mol PDF value is 2038.35400, right? So this is one way to say that which model is a good model, right? So this is not the only way, right? So we have to also compare the energy profile. So we will take this second model and we will go for the further evaluation. So let me erase the annotation. So what we are going to do is that we are going to create some energy plot for graph. So go to the script, go to set 1, and we have to choose this plot profile. Okay, so this is the script I am going to evaluate the model. I'm going to create some profile, energy profile graph. So let me open this plot profile using Notepad++ just to show you what's the content of this. So here you can see that so it is asking for some input file. So before that, import PyLab, import modeler. You have to install this PyLab as I mentioned in the softwares which are required. So you should have a modeler for this, and here the alignment file name. So let me annotate that. So the first input file is the alignment file name, so which is given here. Okay, so we should have this file in the current working directory, and 1BDME profile. Already this file is generated, and we have that in 1BD. Okay. So we are going to evaluate the template and model. So once if we evaluate the template and model, so based on that evaluation, we can do the plotting. So for that, I have copied the 2 files, evaluate template and evaluate model, from the script folder. So let me show what is the content of evaluate model. So I'm opening using the Notepad++. So let me annotate this to make you to understand that. So this is the input file for evaluate model. So we have chosen the tbldh.b99990002 is the it's one of the better model generated among the 5 models by the modeler. So we have to input this file to this. So the program is going to output a profile file for the corresponding tbldh, right? So let me delete the annotation. So we will run this script now. So I'm going for the command line. So the command for running this is evaluate mod 10.1 evaluate model.py. I'm just going to run this. So it is running. Import site failed, use -v for traceback. So it's going to generate evaluate model.txt file as the output file. So as of now, okay, so here it generated the file. So let me open this file using text editor. Okay, so this is the output of the evaluate model. Okay, so it made a lot of calculation, and it has given the energy values, right? So in the similar way, I'm going to evaluate the template. So I just show the content of evaluate template. So in case of evaluate template, the input file is the PDB file, which is used for modeling, which is used as the template for modeling. So it is going to generate a report file called as 1bdma.profile. So we will just run that file. So now the command is it's not going to be evaluate model, it's going to be evaluate template.py. So let me run it. So it is running, and it generated a new evaluate template text file, right? So which contains the energy for the evaluation. So the process is over now. So now we are going to generate the plot. So for plotting, so we have to copy the plot profile. So already I have copied the plot profile script and pasted here, plot profile.py. So let me show this file in Notepad++. So here we have to input the profiles which we have generated in the previous step for the target and the template. So this is corresponding for the template and this is corresponding for the target. So no changes are required here. So I'm going to just run this. So plot profile I'm not going to run in the command modeler command prompt. So I'm just going for the Python. Okay, because for plotting this, again I show this plot profile.py. So if you look at the plot profile.py, so it import two modules. One is the modeler, another one is the PyLab. So accessing this PyLab through modeler command prompt is challenging. So better I'm going for the GUI of the Python. So let me go for the GUI of Python. So ideally Python 3.8.32. So from here I am going to run this script plot profile. So let me show how I am running this. So yeah, the window is open here. I am going for file, open. So I am going to open this plot profile file. So I have kept this file in desktop, and I have kept it in the modeler needed files inside the model current working directory, plot profile.py. So I just opened this file. Okay, so here the Python script is open, and I'm going to execute through run module. Okay, so it is going to generate a graph. So let's see. Okay, the process is over now, and we have to see whether any new image is generated in the current working directory. Yes, dope underscore profile is the image file which is generated, which is the output from this step. So I'm just going to open this to show you the plot. Okay, so here this is the plot which I got. Let me zoom this. Okay, the zoom option is not working. So anyway, this is the plot which is made here, and the red color is the energy for the model, and the green color is the energy for the template. So so this is the plot what we got, and on the x-axis we have the alignment position. On y-axis we have the dope, right? So let me close this. We got the plot, and so let me go to the modeler website. Yeah, here we have the I think I can we got the very similar plot here if you look at this, right? So we got the same plot like the one given in the tutorial, modeler tutorial. So this is how to generate the plot. So in this plot, if you look at between here 90 and 100 amino acid, so probably in this region, okay, 90 and 100, we can say that some issue with the energy, okay, between the energy of the template and the target, so which is clearly shown here. You can see there is a model is having higher energy, very high energy. So here at this point the model is having a very high energy, right? So probably we have some issue in this region between 90 to 100, right? So if we go back to the alignment file which we have generated between the target and template, so let me open that alignment file. So this is the alignment file which we got between the target and template using the align 2D. So yeah, this is the region what we set. So if we think of why we have the energy, a higher energy for the model in this specific region, because we have some big gap here. Okay, so that could be probably the template is not covering this region of the target. Okay, that could be the possible reason for why we have some issue in that specific region between 19 to 100. Okay, so this has to be, we have to overcome this. So if we think of how we can overcome this, so the one possible way is that we can find some other template which can cover this specific region. Okay, since this template 1B DMA is unable to cover this region, so we can look for, is there any other closely related template that we have identified using compare.py that can that is able to cover this specific region. So then we can go for the multiple template modeling. It's a kind of advanced modeling, right? So that is one way to rectify this issue. We can go for multiple template modeling rather going for the single template modeling, right? So for that, what we are going to do is that so we move on to the advanced modeling part. So okay, so first thing what we are going to do is that we are going to add a few more structure rather taking only one structure. So we are going to choose this a 4 template that we have chosen in the first step. One is 2MDH. So let me write it here. These are the 4 templates that we are going to use for the multiple template. 2MDH A. Second one is 2MDHB, 1B8PA, and 1BDMA. Right, so you can choose as many templates as you want. These are the templates which I am going to use for demonstrating how to use multiple template for modeling, right? So for using multiple template, the procedure is slightly different. So we need the PDV structure of this 2D, 2MDHA. We need the structure of 2MDHB. So we need the structure of 1B8PA and 1BDMA. So for 1B DM and 1B8P, we already have the structure here. So for this 2MDHA and 2MDHB, we have to copy the file. So let me copy that file. So I have it in downloads, and I copied this file and I kept it on the GCR. You can directly download from there. So here I am going to copy this file which is 2MDH. A and B both are present there itself. Okay, so I just copy this and paste it. I have given access for all the files on GCR, right? So no need to worry about that. So I copied this to my folder here. Okay, model. Yeah, Control V. So 2MDH is already, actually this is present. It should be present in the PDV. 2MDH. Yeah. You can copy from the file given in the GCR, right? So no issues. Okay, so let me go to this. Now what I'm going to do is that I'm going to make alignment between the structure of this 2MD, 2MDHA, 2MDHB, 1B8PA and 1B DMA. So how to do that? For doing that, we need a script, a Python script. So I just go for script set2. So the script is salign. Okay, so the main job of this salign is it is going to do the structural alignment. So I copy this file to the model folder. So let me show that file to you. I'm opening this file using text editor. So the input is that the PDB files that we had to compare. So we have chosen this 4 as the this 3 as the suitable template, 2MDH, 1BDMA and 1B8PA. Okay, so these are the 3 templates. We assume that the good template for going for the multiple template. So we have chosen this, and we have downloaded the PDB file corresponding for that. So it is going to create a file called as fm00495.pap and fm00495.ali. That's going to be the output file. So which will contain the multiple sequence alignment between the templates. We are not including the target. Just we are going to align the template first. So let me run that script. Okay, so since we have the all the required files, PDB files and the script file, so let me run the script. So running the script mod 10.1 space salign salign.py. So if I run this, it will do the structural alignment between the PDB structures which we have chosen, right? So it outputted the file. So the output file here is output file from the salign is so let me check it, the output file. So the output file is fm00. Okay, so we had looked for fm00, it's there. So here we have the output file fm00495.ali and fm00495.pap. So I am opening this using text editor. So as I said that we have chosen this 3 PDB file. We assume that this 3 PDB files can cover the region between 19 to 100. Here it's very clearly listed. So let me annotate this. See, if you want to use all the 4, you can use. Actually, we have only 2 here. Okay, so A chain, B chain. 2MDH contain both A chain, B chain, and 1B8P also contain A chain, B chain. So only thing we have added extra is this 2MDHA. We assume that this 2MDHA which can cover the region between 90 to 100. This region is almost this is covered by any one of this template. Okay. So now if we take this and if we align that with the target sequence, we will came to know whether that gap is filled by any of these 3 templates or combination of these 3 templates, right? So for that I delete the annotation. So I'm going to use this alignment for aligning with the target sequence. So for that, so we need another script which I kept it in script step 2. So that is align 2D mult. Okay, so the main job of this align 2D mult is it is going to make the alignment between the target sequence and the set of templates which we have aligned in the previous step using the salign. So I am going to show you the content of the script using text editor. So here so we have the structural alignment output file fm00495.ali and this is the target sequence. So this script is going to make alignment between the previously aligned structure with the target sequence tvldh.ali. Very simple script. So I'm going to run this script now. So so the script file name is it's going to be align2d.mult. align2d.mult.py is the script. So I'm just running this script. So it's going to make the alignment. Job is very fast. It completed. So the final output file from this is so let's check what's the final output name that we have given in this file. So open this using text editor. So the final output file is a tvldh.mult.ali and tvldh.mult.pap. So here we have the final output from this step. So I'm just going to open this tvldh.mult.pap. So it will be easy for us to see the alignment. Yeah. So now the three templates here. So this is the first template, this is the second template, and this is the third template, and this is the target sequence. So definitely we can say that between 19 and 100, right? So this region. So this template, okay, so either this or this or this, they cover the entire sequence, right? So this is something advantage. Now we can expect that the energy issues that we had in the region of 19 to 100, that can be resolved if we model using this alignment file. If we model with the help of the three templates, 2MDHA, 1BDMA and 1B8PA. So we are going to run this. We are going to model using this three template now. So for modeling, we need another script. So for that, I kept in script and set to. So and the file name is model mult. Okay, so first time we have used model single for modeling. So now the script is model mult. So I pasted the script. So let's see what's the content of this model mult. So it's very simple. So we had to give the previously obtained tvldh mult.ali. In the previous step, we got this file as the input file and the known structure or template structure. So we have used 1BDMA, 2MDHA and 1B8PA, and the target sequence is tvldh. So we are asking the software to output 5 models. So it will output 5 models. So we can run this now. So for running this, I have to slightly change the command mod 10.1 space. So it's going to be model mult. Okay, so I'm just going to give model mult.py. Okay, so just enter, and it is a time consuming process because we requested for 5 models and we have to wait for that. Okay, so finally we got the model. 5 models got generated. So actually it overwrite this files. So now the new file is tvldh with the same file name, right? So these are the 5 files which got generated now. So we'll see the energy of this. So here model mult, this is output file. So I'm just opening this file using notepad. If we go down here, and again it output only the mol PDF value because we did not ask for the dope energy for this. So yeah, so now what we can do is that we can evaluate the model. So for evaluating the model, so I'm going to take this evaluate model file from set 2 of the script, and I am pasting that to the model folder. So I'm just going to replace the previous one, evaluate model. So let me show the content of the script. We can easily understand. Okay, so here we are going to now evaluate this model tvldh B999001.pdb, because this time this model we assume as the WIST model based on the mol PDF. So we are going to calculate the energy profile for this model tvldh B999001. So let's run this script. So for running the script, I just go to the modeler. So I'm going to change this to evaluate model dot py. Okay, just enter. So it now evaluate the model. So already we have evaluate template. We have the output for evaluate template. So now we can plot this now graph, and we will check is there any difference we got, right? So is there any energy between the 90, 100, 110? Is there any change whether the energy of the model is reduced or not? We have to check that using plotting this. So I just go for Python. IDLE Python 3.8.32. So where I'm going to evaluate this evaluate model. So for so we have completed evaluate model and evaluate template. So we have to go for plot profile. Okay, so we can go for plot profile. So let me show what is the content of plot profile. So once again, already we have used this plot profile. So it's going to take the profile of TVLDH and the profile of 1B DMA, right? So I just go and open file, open. So I kept all the files on desktop folder. So I'm going for desktop. So where I have modeler needed files. So model. So in which I am going to open this plot profile. Okay, so it takes the model evaluation and template evaluation. Evaluate template and evaluate model is the input file for this. So once if we run this, it will generate the output image, right? So go to before that I just replace this the name of I just change the name of this dope profile. Let me put this as 1 or single. Okay, this is the output we got for single template. So because the file will be over right now, so I just go for run, and I just give run module. So we have to wait for the completion. So after the completion, it is going to generate another image, dope profile. So let me check. Is there? Yeah. So it generated another dope profile image file. So I just renamed this as multiple, because this is the profile we got using multiple template. I just made it as multi. So I'm going to open this image. So we'll see here, is there any change that we got in that specific region? So we can compare that with a single. Yeah, definitely we can say that a lot of improvement in the model. So here if you look at in this region, because of that gap, the energy of the model was very high, but here the energy of the model in that specific region is drastically, it is improvised because of using the multiple template.